Now, for examination, it's important that we learn how to use vectors to solve geometric problems. This is a very useful theorem that often appears in examinations. This theorem says that in a quadrilateral ABCD, if vector AD equals to vector BC, then ABCD is a parallelogram. Let's try to unpack to understand what this means. We are told that vector AD equal to vector BC. This tells two things. They have the same magnitude, meaning they're the same length, and they have the same direction. And if two vectors are equal in both length and direction, then they must be parallel and equal in size. So this means that AD is parallel to BC and AD equals to BC in length. That means the magnitude are the same. Therefore, we know that one pair of parallel sides of this quadrilateral ABCD are equals and parallel. We already know earlier that one pair of parallel sides AD and BC are equal and parallel. But to fully show that ABCD is a parallelogram, we also need to show the other pair of parallel sides. In other words, vector AB and DC are equal and parallel as well. So now we need to prove that vector AB equal to vector DC. Let's go through the steps. We know that vector AB equal to vector AC plus vector CB. C is the common point here, and we know that AC plus CB will give us AB because by the triangle law of addition. Now, we know that vector CB, we can think of it as the negative of vector BC. So from vector AC plus CB, we can write it as vector AC minus vector BC. And earlier on, we already showed that vector BC equal to vector AD. So now we have the equation vector AC minus BC equal to vector AC minus AD. We know that minus AD, the vector minus AD, is just simply the vector dA. So now we have vector dA plus vector AC, and once again A is a common point, and by the triangle law of addition, we have vector dA plus vector AC to give us vector DC. So now we know that vector AD equal to vector BC. That means AD is parallel to BC. We also know that vector AB equal to vector DC, meaning AB is parallel to DC. Therefore, both sides of the opposite sides are equal and parallel. So we can conclude that ABCD is a parallelogram.